so you may have some basic idea how the self-driving car running on the road. So just waiting for the laptop or rebooting. Thank Tony to invite me here. Today I'm very glad to be here and share this talk with you guys. And I'm also very happy to meet all of you because you are so young. Actually, I can use this a little bit of time to talk about my. Okay. Cool. Okay. So this is me. My name is Yunfei. I come from the mechanical engineering department at UBC. My major is robotics. Specifically, is about the autonomous navigation. So this is me. For the autonomous navigation, we know that it can be for robotics and also it can be for self-driving car. So in this talk, I'm going to first introduce some basic concepts of robotics and then introduce how can we apply these robotics technologies into self-driving car. So in this way, you can have a sense that how we can learn this knowledge, technologies, and how to apply it into the real world. And I believe that all of you have seen robots or heard robots, especially from movies, right? So this is the from Terminator, right? And this is a very recent movie called Big Hero 6. This is a Jabby, right? Okay, that's great. So I want to ask you a very, very, very basic question. So what is robot? Or see, what's the definition of robot in your mind? Who can tell me? Just give a try. There's no right or wrong answer. But this is give you an idea about how you think what robot is. Try it. Can I pick one?
Yeah, sure.
Okay, maybe you. So what is robot, you think?
It's a machine that runs on a program to do certain tasks.
Bravo, this is good. Yeah, this is a good answer. Who else want to try? I'm going to find a beautiful one. How about over there? You. Yes, you.
Artificial intelligence. Man-made solution.
Okay. Yeah, that's good. Actually, for robot, though the question is very basic, but the answer actually is very difficult to answer. The reason is that robot is a kind of a platform that combines almost every technology nowadays, from hardware to software, from mechanical to electrical, almost everything we can think of. That's why that actually for the definition of the robot, it's very hard to give a common one. But today, I found one that from Wikipedia that I think is at least met my idea about the robots and also met the topic we are going to talk about today. So here, robot is a mechanical or virtual artificial agent, usually an electromechanical machine that is guided by a computer program or electronic circuitry. So from this definition, actually we can see that basically we can divide the robot concept into two main parts. One is for hardware things, and another one is for software things, which you are concerned about today, like the software, computer science, computer engineering. All of this actually can be applied into robotics area. Robot is almost every country, in the world, put their big resources on developing robotics technologies. And it can be applied into many areas. For example, I'll give some examples here, like in the industrial area, in the automotive manufacturing area, military and water, space exploration, and the serving people area. So, here I also want to ask a very basic question in your mind. What do you think? Why robot is so popular? Okay.
Because people are lazy. Robot doesn't let the robot do it.
Actually, good answer. This is a good answer. So who else want to try? Yeah.
Robots are too precise. So like once you program it, they kind of hardly make error. But if you program it really well.
Yeah, that's good. Actually, we can put all of your ideas just into one point because we need it. Why we need it? Because sometimes we know that our human beings have limited ability. So, but the robot can help us do something that we can't do or is very difficult for us to do. For example, just in the space, our human beings can't live over here. But robot can. And robot can do some, like you said, precise work. And also it can be doing very boring tasks without any complaints. And you usually don't need to hate it anymore, right? So that's why we need it. And actually this is a very important principle behind the research we are doing. Why we're doing research, or why we want to learn some major, that is because there is a necessary behind that. We want to achieve something, and these achievements can help our human beings to, or see that we are so lazy, right? And we want these technologies to help us, to relieve us, and give us more fun time to play video games or to have sports. So now we're gonna go to the main topic about today. Actually, nowadays with the development of computer science, intelligence, artificial intelligence, information technologies, and hardware technologies, the robot, the concept of robot has been expanded into our almost every aspect of our daily life. Give you an example. Nowadays, almost everyone have a cell phone, smartphone, and now we are developing smart grid, smart house, smart car, which is going to mainly talk today, and smart industry. So, based on the definition of the robot, actually we can consider each of this as a robot, which means that robot doesn't mean it's just kind of a humanoid robot. It can be something else. And I will use an autonomous car or self-driving car to give you a basic idea how the hardware, software working over there, and how we apply the robotics technology into the car. So this is the outline about the topic. I'm going to introduce first, why we need autonomous car. This is a very important principle. Everything we want to do it, we first need to figure out why. And then I will introduce some development level, to give you a basic idea. Now, how far we have already arrived, and how far we still have to go to reach the point that we expected. And then I will give you two main functions of autonomous car, and see how the software or see the algorithm, how the algorithms work over there. Then at last I will give you an experimental demo to show the whole idea of how the autonomous navigation works. Okay, why we need autonomous car. Here, I want to ask a question now. I want just directly go to the data that published by the U.S. Department of Transportation. You know, from this data, we can see that actually 99% of the accident is caused by human beings' mistakes. So a very initial idea is that why we don't let the car deal with some driving rules and make decisions for us when we're driving, and so that we don't need. And because robot can be very precise, it can strictly follow the rules. We don't need to worry that it can break the rules. So in this way, we can decrease the accident rate, right? And also, if we have the autonomous car, it can also free our human beings from the long boring driving. We can use this time to do many things, like you can review your assignments, you can talk with your family, or you can just watch some of videos. And also that some other people, like the disabled people, elderly people, they can't drive by themselves. So autonomous car definitely very necessary for them if they want to experience the normal people's driving. Okay, so you may saw some autonomous car, on the movie that can do this, can do that, can save people life. I think there is a movie talk about autonomous car that he is a cop, and the car is also artificial intelligence cop, and the car can save the cops from many dangerous tasks, and they can talk, they can communicate with each other. Also, from the Iron Man, the suit he designed can also talk. It's that kind of artificial intelligence robot, right? So now I want to show you how far we are from there. So let's see that the situation I just described is the level 6, is level 5. You can see this is full automation. Actually, according to the Society of the Automotive Engineer, they would like to divide the full levels into 6 levels. So from the 9 automated to 4 automated, actually we are just going through now. And where are we now? Here, the red line is that, at least from the point of my view, that we are here. But I will give you some historical report about some examples that what we did before. So, at level 1 and level 2, actually we already achieved it. So, in today's car, almost every car has ABS system. And in nowadays luxury car, they have the blind spot detection, parking assistance, lane assistance, like that. But until this level, we just see that it's half automated car, because we still need our human beings to be driver over there and give some the instruction to the car. The car can't do something itself. It can just give us some warning that let us judge that, oh, this is a dangerous situation, we need to do something. This situation changed until 2007. And at this point, at this event, it's called the Delta Urban Challenge holding by U.S. Defense Department. We researchers and scientists consider that this is the groundbreaking point that we really have a self-driving car. So I will play a video here to give you a sense of that.
「 go 100 km to an air, these cars went nowhere. So we decided at Stanford to build a different self-driving car. We built hardware and software. We made it learn from us, and we set it free in the desert. And the unimaginable happened. It became the first car to ever return from a development challenge, winning Stanford $2 million, yet I still hadn't saved a single life. Since our work is focused on building driving cars that can drive anywhere by themselves, any street in California. We've driven 140,000 miles. Our cars have sensors on which they magically can see everything around them and make decisions about every aspect of driving. It's the perfect driving mechanism. We've driven in cities, like in San Francisco here. We've driven from San Francisco to Los Angeles on Highway 1. We've encountered joggers, busy highways, toll booths, and this is without a person in the loop. The car just drives itself. In fact, while we drove 140,000 miles, people didn't even notice. Mountain roads, day and night, and even crooked Lombard Street in San Francisco. Sometimes our cars get so crazy, they even do the little stunts. Oh my God! What?
In situations like this, you will increasingly wonder why he should.
We're going to get there even sooner than we think.
Okay, the reasons for
each traffic light has to be correctly identified under all weather and lighting conditions.
I didn't drive anything, I was just sitting in the car. I'm amazed about how smooth and how simple it looks, even though there is a lot of technology behind the car, so I'm very encouraged.
New, more precise. Now, the arguments I most often hear against self-driving cars, often.
Okay, so actually, we can consider this is the first generation of autonomous car because we can see that it still has our traditional components of the car, like the panel and the steering, right? So we still need actually. For this one, it said that it can be successfully running on the road, but it's still there's still some accident happen. The reason is that if the highway situation is very normal and nobody will break the rules, then it can be successful. But however, if somebody drunk, they didn't drive it very politely, then maybe the car can't recognize this situation and make a wrong decision. That's why that the lawmakers still can't recognize the car as an autonomous car as a safety car, and they still can't accept it. Though in some states of the United States, they already let the car go on road, but almost I think 80% of the states still didn't get the rule path. But this can't stop the scientists and researchers continue to research on this. Last year, Google published their second generation autonomous car. Let's see what that car looks like.
It was a big decision for us to go and start building purpose-built vehicles for this. And really, they're prototype vehicles.
they were a chance for us to explore what does it really mean to have a self-driving vehicle. But in the small amount of time we've been working on it, we have functional.
So if I had a self-driving car, I could spend more time hanging out with my kids or helping them with their homework, even just tending to them.
And it's really exciting to see the progress we've made. The opportunity for people to just move around and
I love this!
Okay, so this is the step now we have arrived. Because the Google thinks that the real autonomous car don't necessarily have the steering wheels or the panel. You just let the passengers sit on it and let the car do everything else. But I would say that it's still far from it to be commercial. Though some of the big companies announced that they will achieve that by 2020, it will bring this commercial self-driving car into our daily life. But personally, I doubt it, because from nowadays, achievement, it seems that it's still, at least the people don't trust it. You can't give your life just to give a car, right? So okay, now let's go to the next part. This is the technologies actually needed for autonomous car, and also let's see for robot. Now from this point, we consider autonomous car as a robot. Besides the car itself, we consider it a hardware. For the autonomous car, it still needs some extra important sensor to help it sense the environment around it. I give at least some example here. This one is called IMU, and it can give the position and it can give the velocity and acceleration of the car. And the GPS, we all know that it can give the position of the car, right? And the camera and the LiDAR, which is kind of our eyes, which can give you a sense the objects that are around the car. And also the LiDAR car is a little bit different from the camera, because from the camera we can see some views, some color views, but the LiDAR can only give you some points. It's called cloud points. It's just, you can imagine some randomly set spring cloud points that around you, and this cloud points can form some shapes, and then the robot or the car can conclude that some information from these points. Okay, once you get all of the information from many sensors, we send this data into a computation part, or say the brain of the robot. Actually, here is the real computer programming or computer science things happen here. We need to use these programming languages, to program some functions that can help us deal with this data that comes from the sensors. And after this step, it will give a car the eventual controls or instructions that the car how to go from one point to another point. So this frame is kind of a typical setting of the sensor that how set the sensors around the car. This picture gives you a simulated environment, how the car sees the environment. This is the real environment view, and this is the simulated one, which means that we can see the robot or the car extracted the information from the street, and it marked the object that detected by the sensor with different colors and shapes, and we give some training for the car and let it learn what kind of object it is. Like, is it a car, or is it a pedestrian, or it is a cat or dogs or So the final is going to execute the orders from the computation part. Okay, now we are getting to the point that how the robotics technologies can be applied to the autonomous car, because in previous slides I always jump from car to robot or from robot to car, and here I will give you a sense how we can combine these two concepts together. This is a mobile robot, though it doesn't look like that, right? This is the robot that I use in my lab. I use it as my research platform because we don't have a real car here. So we just use this mobile robot as a platform to test my algorithms. So how this one can connect to the autonomous car? Here. Simple but important. This is the model that describes this mobile robot. And this is the model describing the car, four-wheel car. And actually, though they have a different forms, shapes, or what is shape, but the model behind these two different shapes are same. I can just consider these two as one unicycle model, like here. And all of my algorithms just can be done with this very simple model. This is the magic of the scientist. Sometimes you may see that, oh, it's very different, but actually the principle behind the different shapes is the same. Okay, so how this basic concept, I'm going to show two functions of the autonomous car. One is pedestrian detection. Why is this important? Because if we want to get the car on running the route, the first thing we want to make sure is safety, especially safety for our human beings. So, first thing, if we want to keep our human beings safe, we need to where the human is. That's why that we need to first detect where the pedestrian is. And actually, in our car, there are some similar function that can help us do this. But it can only give us some warning, not directly give the order to the car. Because the precision is not so 100% accuracy. I will give you a demo that I did in my lab to let you have a concept why detecting people is not so good right now. How can we turn off the light? Because it's kind of